Hello everyone. In this last problem solving video, we are essentially asked a problem which involves concepts from alcohols, phenols and reactions of ethers. So the question that is given here is simply a match the following, where we need to match the elements in column 1 with elements in column 2. Let's try to inspect all the elements in column 1 and we can see that we have methanol, Kolbe's reaction, fermentation, conversion of a secondary alcohol to ketones, Williamson synthesis and Revathi reaction. We can easily note that Kolbe's reaction, Williamson synthesis and Revathi reaction can be easily identified because these are named reactions, and we are also very familiar with the products obtained in each of these named reactions. For example, Kolbe's reaction is nothing but conversion of phenol to orthohydroxysalicylic acid. We know that phenol gets converted to phenoxydiene, which being highly reactive reacts with a weak electrophile like carbon dioxide, giving us orthohydroxysalicylic acid. In case of Williamson synthesis, we know that it is a method to prepare ethers where reaction of an alkyl halide takes place with sodium alkoxide. Now, Revathi reaction, a very important named reaction, is usually used to introduce a CHO group or an aldehyde group to phenol at ortho position. That is used to convert phenol to salicylaldehyde. Now, as you can see, since these are covered, we can easily map the rest of the elements given here. We have methanol, fermentation and conversion of a secondary alcohol to ketone. And we know that methanol was previously also called wood spirit. And ethyl alcohol is the alcohol obtained by fermentation. You can easily see that conversion of a secondary alcohol to ketone takes place in the presence of heated copper at 573 kelvins. So now we can see that it is very easy to obtain this correct matching, which is 1 to 4, B to 1, C to 2, D to 3, E to 6 and F to 5. In order to understand better, we have given a glimpse or a summary of the named reactions here: Kolbe's reaction, Revathi reaction and Williamson synthesis. I hope you are very clear on how we have arrived at this particular solution. Thank you.